Hello again. Sorry we had another interruption. Had somebody drop by. I had to sign some legal papers. Anyway, this goes through -1, 0. So if we wanted to say sine 180, that would be 0 because the y-coordinate is 0. Cosine of 180, because the x-coordinate is -1, is -1. Tangent of 180 is y over x, and that is possible. 0 divided by -1 is 0. Then the reciprocal functions, cosecant of 180 is going to be 0. Reciprocal of 0 is 0. Secant of 180, the reciprocal of -1 is -1, and you can't actually take the reciprocal on the cotangent. That one is going to be undefined because that is x over y. Okay, sorry for the pause there. All right, now looking at the bottom of the page, we're going to talk about reference angles. And I have this graphic from the book in there, but I really don't like these formulas implying that you should memorize those to find reference angles. Really, the main thing that you need to know about a reference angle is it is how the angle differs from the horizontal. So this thing I just drew here shows, and that is, you can't see that very well, but that's theta prime is what that stands for. The little hash mark there means theta prime. That means the reference angle of theta would be this angle right here. So the whole thing about reference angles is that we want to use them to make everything basically into the first quadrant. So if we can find our sine, cosine, tangent of an angle in the first quadrant, then we can find it for an angle anywhere else. So this one differs from 180 in that direction. So let's say that, I'm just guessing on this, this is 130 degrees. Okay, then this theta prime would be 50. Okay, so 50 is a first quadrant angle, and we don't have to remember as much if we have a first quadrant angle. So this one is the difference that's below the horizontal, so that reference angle is this much, it's this much below. So we would want this entire angle subtract 180 because that's the difference there. On this one, we want 180 subtract the 130 that we had. And in quadrant 4, again, the reference angle is how much different it is from horizontal. So we want just this amount of the angle there. So that's what reference angles are. Just remember that they always differ from the horizontal. They're not, even if you have an angle that's like really close to the vertical and you want to be able to do that, that's not the reference angle. That is not the reference angle. The reference angle would be this one. How does it differ from horizontal? So the nearest place to horizontal. So all reference angles should be less than 90, or if you want to do radians, less than pi over 2. Okay, so let's draw a little picture to help us think about where this is. -130, remember that's going backwards or clockwise, and -130 would take us to about here in quadrant 3. So the reference angle we want is this. Okay, and so if this is 130, then this is going to be 50. So our theta prime in this case is 50 degrees. Okay, for 5 pi over 3, if you remember from 9.2, 5 pi over 3 is an angle about here in quadrant 4. And so this is the angle 5 pi over 3. Its reference angle is going to be, if you remember from those spokes on the wheel we looked at for those radian angle measures, this would be pi over 3, that angle right there. So theta prime here is pi over 3. All right, 220 degrees negative. For this one, negative 220 degrees would be over here somewhere in quadrant 2. It's goes a little bit beyond 180, and that's what we want to know for the reference angle. How much further did it go past negative 180? And that would be 40. So a positive number of degrees. How far is it differing from the horizontal? And this last one, 15 pi over 6, that one is so close to being a full turn around the circle, it's only 1/16 less than that. I probably didn't draw that small enough to be 1/16, but theta prime in this case is pi over 16. So there we go. All right, this little thing is a little reference tool to help you know where each function is positive and negative in which quadrants. And notice that in quadrant 1, just like with x's and y's, since all of the functions have to do with either x over r or y over r or x over y or y over x, if they're all positive, then they're all going to be positive over there. And over here, lots of things are positive. I'm sorry, lots of things are negative because this is a negative direction. And so it's only the ones that are negative divided by negative, which tangent and cotangent are, that are positive. Over here, cosine or x's are negative, and that makes the secant negative, and also the tangent and the cotangent negative. Sine and cosine are still positive there because y is positive in this area. Over here, x is positive, but y is negative, and so that makes the sine and the cosecant negative, and also the tangent and the cotangent negative, because they're going to be a negative divided by a positive. Okay, so using our reference angles, let's look at this. So in example 4 down here, we got negative 240. That's going to be an angle that is almost all the way around to the vertical axis there, but it's 30 degrees short. So this is our negative 240. The reference angle is going to be this little part here, which is 60. So this is going to be the same thing as the opposite of tangent 60, okay, because from our little reference tool up here we see that tangent in this quadrant is negative. So if we find the tangent of 60, and if you remember back from the front page, it was root 3. Tangent of 60 is root 3, so the opposite of tangent 60 is negative root 3. Okay, it might be helpful to have from your notes in 9.2, there was that one handy little graphic, so I can show it to you here. So here was, well, that doesn't have the, well, you can draw that and see that this is going to be 1/2, and this is going to be root 3 over 2 here. So that's how we end up getting root 3 for the tangent of 60. Okay. I'm going to show you a better way to remember that next time. Okay, so anyway, so that's negative root 3 for that. On this one, 17 pi over 6, that's more than one turn around the circle, because 2 pi over 6 would be the same as 12 pi over 6. So this is 17 pi over 6 is the same thing as 12 pi over 6, which is 2 pi, and 5 pi over 6. Okay, that's 17 pi over 6 right there. But this we can eliminate because it's that's just one turn of the circle. So this is going to be the same thing as cosecant of 5 pi over 6. Okay, because this is one turn of the circle, and 5 pi over 6 is how much beyond one turn of the circle. So that's going to be the same thing as, well, if we know what the sine of 5 pi over 6 is, we can just take the reciprocal of that. So the sine of 5 pi over 6 is, that would be over here, 5 pi over 6, that's there on the circle. And that would be positive 1/2. So this is going to be the same thing. Okay, it's 1 over it's the reciprocal of the sine of 5 pi over 6, which will be 1/2. The reciprocal of 1/2 is 2. Okay, so this sine here would be 1/2. So the cosecant is the reciprocal of that, which is 2. All right. Cotangent of 30. Well, this is the same thing as cotangent of 30, the opposite of cotangent of 30, and that is because this is negative 210 would be like so. And so this little part of it right there, that reference angle,